design of a project in transportation engineering. So this is the upgrade and a realignment of a 4-kilometer road which is based in Mpumalanga, as you will see on the locality plan. I would like to acknowledge Mr. Carlos Ngwanqa for assisting me in putting up this project together. Mr. Carlos Ngwanqa is a PR Tech Eng registered. As the project brief, we're required to upgrade a gravel road or reconstruct a road that has reached its design life cycle to a standard surfaced 4-lane two-way. The designer, which is myself, I had to generate further alignment of the road by using the commercially available geometric design softwares. I've used Civil 3D student version, which was provided. I've also used this software to calculate quantities for both the hydraulic structures, which is for drainage, for the road, and for the earthworks. The following design guidelines were used: TRH 17, TRH 4, UTG 1, drainage manual from Sanral, and the geometric design manual also from Sanral. So all these were available online. Some were also available from my study material. I've used these guidelines, and these are the generally used guidelines in South Africa for the design of roads. For the drainage design standards, I've used the standard specification for municipal civil engineering works from the city of Tshwane Metropolitan Municipality. In terms of the drainage and the existing drainage on site, in terms of the culverts, we've done a visual inspection of the culverts, and we've decided that the culverts, which is 5 of them, which are available on site between chainage 0 and chainage 4, we are just going to clean them, remove all the silt that is picked up in the culverts. One culvert will be upgraded from a 300mm diameter stormwater pipe to a 750mm stormwater pipe crossing under the road. Subsoil drains will be provided in cut conditions. We have identified that there are areas where water is not draining, underground seepage, so we will provide subsoil drain just to intercept that water and to prevent it from damaging the road layers. V-drains, existing V-drains, there are existing V-drains on the road. The only challenge is that they have been damaged, and as such, it is our opinion that it will not perform and drain all the surface water away from the road as it is required. So we are going to reconstruct the V-drains from chainage 1 to chainage 1.24. Stormwater pipes that we have discussed, the 300mm stormwater pipes will be upgraded from 300mm diameter to a 750mm diameter, which is going to cross under the road at chainage 1, and that is exactly where the V-drain is going to be daylighting, and we'll also have the subsoil drain running under that V-drain. The University of South Africa Department of Civil Engineering has appointed myself, Colin Matawati, for the upgrading and realignment of Ketlembane Road. The realignment and the upgrading of this road requires me to do the visual inspection of the road, traffic analysis or assessment of the road. This particular road is situated in the city of Mbombela local municipality in the Mpumalanga province. The importance of or the need for us to upgrade this road, it is because within the village itself there is no adequate road infrastructure. This road, if upgraded adequately, will serve as a collector and can also assist the locals in moving around and improve business in the area because there will be accessibility. Preliminary investigation, which includes the visual inspection. We undertook preliminary investigation visuals, and while working the road, we identified that there were some areas where they've got deep ruts, which if you put it under the edge beam, you've got more than 10 millimeters rut. Potholes were also identified on the road, very severe potholes. Raveling of the surface wearing course, the asphalt was also raveling. And it was concluded that the pavement or the road has reached its terminal life stage. Traffic assessment. So traffic counts were also conducted. Over and above that, they were also correlated with RAMS. So RAMS is a system that is used by government, which is the Road Asset Management System, where we've got information such as the traffic volumes. IDP was also considered, which is the Integrated Development Plan of the municipality, where it was also noted that there are future developments that the municipality is envisaging for the area, and that future developments that are going to affect the future traffic volume. So there's an anticipated increase in the traffic volumes in future. We also noted the vehicle characteristics. We've got heavy vehicles, we've got buses, we've got trucks, and that are moving around in that area, and small vehicles as well. In terms of the traffic patterns, we've also identified that during the peak hours, which is in the morning and in the late afternoon, there's a lot of vehicles, especially the buses, picking up and dropping people who work in the neighboring towns. So all this, it's the design consideration, things that we need to design for in terms of our pavement designs and our geometric designs. Existing conditions, geometric design, horizontal alignment. From chain edge 0, which is the intersection, to chain edge 1 plus 200, there is restrictions in terms of the road reserve. This is a built-up area. We cannot go beyond the 16 meters road reserve on this section of the road, as expropriation of land has become a difficult thing to do, because in this area, which is mainly managed by local traditional authorities, it is unacceptable to expropriate some of the land adjacent to the road reserve. In terms of the vertical alignment, there are areas where we need to realign the vertical alignment. It will show on the low sections because the K values in those areas are not adequate. So we need to do a vertical realignment to allow heavier vehicles to go up the hills safely, and also for the side distances in terms of overtaking. This is just to make the road more safer. Existing conditions of hydraulic structures, as indicated, the V drains are damaged. Culverts needs to be desilted by cleaning. Cap inlets also needs to be cleaned. Stormwater pipes needs to be upgraded, 300 millimeter diameter to 750 millimeter diameter, crossing under the road. Daylighting as well. This is the key locality plan. So our road starts from here, the intersection of R522. It extends all the way into the Pinar and Danji village, and then rejoins R521 on the eastern side of the area. This is a 4-kilometer road. As you can see, it's got 1, 2, 3, 4, 5, 6, 7 horizontal curves, and it's got 3 vertical curves. So our proposal, or my proposal, in terms of the geometric and road design, based on the traffic volumes, this is a class A according to TRH4, and which needs to provide a 95% design reliability. ES10, this is also as per the TRH table. This road will have to be designed to cater for 3 to 100 million E80s per lane. So these are the number of vehicles equivalent E80s that this road needs to cater for per lane per year. 3 million to 100 million. In terms of the horizontal alignment, table 3.2.1, we are looking at, for the design speed of 80 kilometers, we need to have our radius at 140 meters radius for that to be compliant. Vertical alignment for operating speed of 80 kilometers per hour. This is for the horizontal alignment, that is 210 meters ready. For the vertical alignment, that's 140 meters radius as well, or length of curve, for it to be a safe road. These are some horizontal curve calculation, design horizontal curve checks. Beginning of curve on the horizontal is at chain edge 1 plus 120. End of curve is at chain edge 1 plus 245. The length of that curve is 125 meters. The deflection angle is 30 Ben. 150 millimeters G1 base, compacted to 98% Mont Ashto, will be imported. 300 millimeters base, C3, which is a cement stabilized layer, will be compacted to 95% Mont Ashto. 150 millimeters of selected G7 for my selected layer, and will be compacted to 93% Mont Ashto. This is a freehand pavement layer that I've drawn. Again, it just gives us the same information that I've provided in the previous slide. We'll have a 40 millimeter AC medium, which is the asphalt continuous medium, 50-70 penetration grade bitumen, 150 millimeters G1 base, 300 millimeters of semi-stabilized sub-base, 150 millimeters G7 selected layer. In terms of the intersections, we've got major intersections, which is 2 intersections, which tie into a major road. We've got 3 minor intersections, which tie in between the road alignment, and those minor intersections we are going to provide edge beams and approach on the bell mouth, as the roads are not paved. So what we have here is a typical long section and the layout of the design. As you can see on this vertical curve here, we'll have to have a cut in order to comply with the K value as indicated. On this section here, on this crest, we'll have to fill it up just to make the slope a little bit flatter, so that we can make the road safe in terms of complying with the K value and the side distance. Typically, what we are also hoping to achieve is we've also flattened one of these, is actually two of these horizontal curves, also just to allow for a safe passage and side distance.